So this is oxidation reduction reactions part 2, assigning the oxidation number. Okay, so we did 56 in the last video, so this is 58 in the book. And same question, obtain the oxidation number for the element noted, but you'll notice that this time these are all, all ions. They all have a charge after them, and in this case they're all negative. They don't have to be. In the case of ammonium, that would be positive. Okay, but most of our anions are negative, or most of our ions are negative pi-atomic ions. Okay, so it's basically the same process. Okay, so they want to know chromium in chromate, CrO4 2-. Okay, so I write down chromium plus the fact I have 4 oxygens. Again, I'm using OX for oxygen because I don't want it to look like a 0. Okay, but this time it's equal to this -2. Okay, all right, so OX is equal to a -2 because it's the only kind I'm going to give you. So I have Cr plus 4 times the -2 is equal to a -2. So Cr minus 8 is equal to -2. So Cr is equal to a -2 plus 8. So Cr then is equal to a plus 6. Okay, same procedure, but this time what's on the other side of the equal sign is different. Okay, I do this zinc tetrahydroxide ion. Okay, I have zinc plus I have 4 oxygens plus 4 hydrogens, and again this -2 means that over here it's a -2 charge. Zinc's what I don't know. Oxygen still a 2-. Hydrogen is a +1. Okay, so it's going to be 4 times a -2 plus 4 times a +1 is equal to a -2. So I have zinc -8 plus 4 is equal to -2. So zinc is -4 is equal to a -2. So zinc is equal to a -2 plus 4. So zinc is equal to a +2 charge. Okay. And for the last one on the slide, all right, I have dihydrogen arsenite ion. Okay. And so it is going to be 2 hydrogens plus 1 arsenic plus 3 oxygens is equal to, this time it's a -1 because there's nothing, all that's written there is a negative. Okay. Again, though, my hydrogen is a +1, my oxygen is a -2. Okay, and these came from those rules. Okay, so I have 2 times +1 plus arsenic that I don't know plus 3 times a -2 is equal to -1. So 2 plus arsenic minus 6 is equal to -1. So it's going to be arsenic minus 4 is equal to -1. Arsenic is equal to -1 plus the 4. So arsenic is a +3. And no, you don't have to show me each one of these mathematical steps. You do at least have to show me this step right here. Okay? All right. So the next slide is it wants to determine all the oxidation number, or the oxidation number for all the elements, I should say. Okay? So chromium 3 sulfate. Okay? So I know that it's chromium 3 sulfate because the sulfate's a -2, which is there. So the 3 must go with the chromium. Okay, so the name for this would be chromium 3 sulfate. So what's the charge on the chromium? +3. If I do the same thing, I have 2 chromiums plus how many sulfurs? 3 sulfurs plus 4 times the 3 is 12 oxygens. And we're back to compounds, so this is 0. Okay, so I need to make a list over here. I know that chromium is a +3. I know that my oxygen is a -2. Okay. Sulfur is the one that I don't know by just looking at it. Okay, so but I need to write this down this time for sure because it wants to know all the elements. So I have 2 times +3 plus 3 times sulfur plus 12 times a -2 is equal to 0. So 2 times 3 is 6, plus 6, plus 3 sulfurs, plus 12 times a -2. Oops, this should be a minus. Minus 24 is equal to 0. So 6 minus 24 gives me a -18. So 3 sulfurs minus 18 is equal to 0. So 3 sulfurs is equal to 18. I divide both sides by 3. So sulfur is a +6 charge. So just to keep my list going. And so I would need all 3 of these for my answer for this question because it wants to know all the elements. Okay. All right. Cobalt seleniate. Okay. Selenium is in group 6A, so seleniate, SeO4, is a 2- charge. So what's the charge on cobalt? If there's no 2 here, then it has to be a +2. Okay. So I know my cobalt is equal to a +2. Oxygen, same as always, is a -2. So I do the same thing. I have cobalt plus selenium plus 4 oxygens is 0 because we're back to compounds. So I have a +2 plus Se plus 4 times a -2 is equal to 0. So 2 plus Se minus 8 is 0. So Se minus 6 is 0. So Se is a +6. Okay. All right, and so that's how you do the oxidation numbers. That's 3 different examples and 8 of those questions within those examples. Okay. The last thing in this chapter is the types of oxidation reduction reactions. There are 3 types of reactions. Okay. A combination, a reaction in which 2 substances form to a third substance. So there's 2 reactants and 1 product. That's how I can identify if it's a combination. Okay. A decomposition is a single compound gives 2 or more substances. So I have 1 reactant and 2 or more products. Most common is 2, but it can be more. A single displacement, a reaction in which an element reacts with a compound displacing the element. Okay, so I'm going to have 2 reactants and 2 products, but 1 reactant is typically a metal, and 1 product is a metal. And it means just a metal by itself, not a compound. Okay? And combustion is when I react with oxygen. So I'm going to have something, I'm going to say something, plus O2 goes to form something else. Okay? I can have combustions could also be a combination. Okay? Or it won't be a displacement. Okay? So therefore, you don't know what that's but you can have it be more than one thing. It can be a combustion and combination at the same time. Okay? Don't ask me what I just did. Where am I at? Right there. Okay. All right. So this is examples I found on the internet. When I take sodium metal plus chlorine gas, I get sodium chloride. That's a combination. Okay. So this is a reaction arrow right here. So I have 2 reactants going to form 1 product. I have decomposition, which is broken down here. I have the Compound, okay, when I burn it, iron plus oxygen goes to form rust. Oh, this one's a combination, sorry. Decomposition, okay, this is mercuric oxide, and it's forming the mercury plus the oxygen there. And this is displacement. This one's not as pretty as the zinc, I'm sorry, the copper sulfate with the iron. And so that was shown on the very first slide of this video. All right, so these are examples of that. And so here it is chemical reactions. Okay, combustion where I have methane plus oxygen goes to form carbon dioxide plus water. We did a lot of those with balancing. Combinations, the sodium plus chlorine goes to form sodium chloride. A decomposition, this is also the mercuric oxide, goes to form mercury plus oxygen, was on the previous slide. And this is the copper plus the silver nitrate, goes to form, so here's my metal, and here's my compound, and there's my compound, okay? The book doesn't have any examples of this, but we'll go over some examples on some worksheets.